Good morning to all the fabulous fives out there. I hope you're well today and rested and ready for another lesson of maths. Reminder to daily make sure that you're practicing your times tables. If you've got any better at them, I'd love for you to drop me an email and let me know. Tell me, Mr. Travis, this is my new record for the 7 times table or the 9 times table or whatever it is, whichever table it is that you're using. So make sure that you practice. The more you practice, the better you'll get. Let's jump into today's lesson. So quick reminders. If you've got an email for me, if you want to tell me about your times table challenge, how it's going, if you want to ask a question about the maths that we're doing, if your teacher's sending you work and you're like, oh, Mr. Travis, I have no idea what's going on, drop me an email at grade5@worksheetcloud.com so that hopefully I'll be able to slot that into one of our upcoming lessons and we can work on it together. Also, once the lesson is over, you can click on the link above and do the worksheet that's there just to check that you've mastered what it is that we've done. I am actually going to jump across to the whiteboard and quickly go through yesterday's homework before we introduce today's lesson. The reason being that the two are not really related. Yesterday we were finishing off fractions and today we're doing something different. So let's jump across to the whiteboard quickly and let's quickly go through it. So we were looking at adding and subtracting mixed fractions. So before we do either of those things, we need to make sure our denominators are the same. We need to first up make this a little bit bigger so I can draw a little bit better. There we go, that's better. So I need to make sure that my denominators are the same. I see that they're different, so I need to do something to one of them to make it like the other. I can see that if I times it by 2, which I must do to the top as well, they will both be 6 at the bottom. So whole number stays the same. 1 times 2 is 2. 3 times 2 is 6. I've just got an equivalent fraction there. Subtract 1 and 1 over 6. That's not maths, that's simply rewriting. Now that my denominators are the same, I can do my subtraction. So I'm going to do the whole numbers first. 4 minus 1 is 3. When I'm looking at my denominators, they stay the same. And my numerator, 2 minus 1 is 1. There's my answer. Over to the second one, I've got 4 and 3 as my denominators. I can't make one into the other, so I'm going to have to change them both. So I need to find something that 4 and 3 both go into. So I'm going to do my times tables on the side, just so that I can check. And 3, 6, 9, 12. There we go. I found it, the first thing that's in both. So I need to make both my denominators 12. To do that to the 4, I'm going to times by 3, which I must do to the top as well. And to do it to the 3, I must times by 4, which I will do to the top as well. Whole number stays the same. 3 times 3 is 9 is my new numerator. 12 at the bottom. Subtract 4 stays the same, doesn't change. Then my new numerator, 1 times 4 is 4, 3 times 4 is 12, and I have my new numerator. Oopsie. Just have a quick look then. 6 minus 4 is 2. Denominator stays unchanged. 9 minus 4 is 5. There's my answer. Looking at the next one, 3 and 5 are my denominators. I need to make them the same. I can jot down the 3 times table and the 5 times table, find out where they have something in common. I normally just do the first 5 of each timetable, and if I need more, I can always add them after that. Oh, don't need more. There we go. We need to make them both 15. So I'm going to times this side by 5, same to the top, and this side by 3, and same to the top. Whole number stays the same. 1 times 5 is 5. New numerator, new denominator, 15. Plus, making sure you get your sign correct. Whole number stays the same. 2 times 3 is 6 over 15. Now that I have the same denominator, I can add. 7 plus 5 is 12. 15 stays the same at the bottom. 5 plus 6 is 11, and there's my answer. Right. Next one, 5 and 2. Again, I need to put them into the same denominator, so 2 times table. Found it. Needs to both be 10. Times by 5, times by 5, times by 2, times by 2. So the difference about D is I didn't give you a whole number, but that shouldn't prove to be a problem. So a whole number stays the same for the first one. 1 times 5 is 5. New numerator, new denominator is 10. Plus 1 times 2 is 2. 5 times 2 is 10. I'm going to add my whole numbers first. So 12 and there's nothing, so that's still 12. Then I'm going to have a look at my denominators. They stay the same. 5 plus 2 is 7, and there is my answer. So I hope that went well. If not, you can always go onto WorksheetCloud and click onto one of their worksheets that looks at adding and subtracting mixed numbers and practice with that. Then I had the following. I needed to put the missing numbers on the number line. There are more than, let me just move my screen up a little bit. There are more than one that would potentially work here, but I'm going to go with the 6th, and that is because I have divided my line up into 1, 2, 3, 4, 5, 6 pieces. So that's looking at 6, and 1 is there, and 0 is there. So at this end, it would be 6 over 6. And this end, it's 0 divided by 6. In other words, 0. So I've got 6 spaces. So if I go back and put these in, I've got 1/6 over here, 2/6, 3/6, 4/6, 5/6, and that would have been more than good enough for the answer. If you were being fancy, you might have noticed that this is also equal to a half. These two are equivalent fractions. This is equal to 2/3. Those are equivalent fractions, and this is equal to 1/3. Those are equivalent fractions. You didn't need to put those in. I'm just showing it to you in case you are one of those people who had. And if we want to look at this middle one again, this middle one is also equal to 2 over 4. But you don't need to worry about that either. In fact, I think I'd rather leave that one out. That might confuse some of you. There are lots of numbers that are equivalent fractions there. Okay, that's going through your homework. Let's jump back across and have a look at what today's lesson is all about. In today's lesson, we are looking at 2 very fancy words, the associative and commutative properties in maths. So tomorrow we'll add in the distributive property as well, and then we'll practice all 3 together. But I thought today, seeing as we've got these big words, we will just work with the 2 of them. In practice, they're not as complicated as their names sound. In fact, you don't always need to remember their names. You just need to know what it is that you can do with these properties. So we're going to look at each of them and with some practical examples, and hopefully it'll make more sense to you. Right, lesson goals today. Understand and apply the commutative properties of addition and multiplication. Understand and apply the associative properties of addition and multiplication. So those are the 2, and we're only looking at them with addition and multiplication. And that is because they only work with addition and multiplication. Let me put myself up in the corner. So the commutative property, which is for addition and multiplication. So for addition and multiplication, we can change the order we do things and still get the right answer. Let's jump across to our whiteboard so that we can look at that in practice. So it will make more sense once we are looking at it in practice. So we'll look at the commutative property first. And what we said is that you can change the order and it won't change the answer. So if I had 3 plus 4, and on this side I do 4 plus 3, I hope you will be able to quickly do that with your mental arithmetic. I get 7, and I get 7. So it doesn't matter which way around we have it. When it's plus, you still get the same answer. So plus, we can change the order and we can still get the right answer. Let me give another example as well. Do that quickly in your head. So if I was doing this quickly in my head, I would say, well, I've got 12. If I first add the 8, that will take me to 20. And then I add the other 10, and that takes me to 30. All of this stuff, the drawing in pink, is actually just happening inside my head. So I don't actually write that down, but that is what I did. I said to myself, well, I've got 12. When I add this 8, it takes me to 20, and then I've still got the 10 left over there. And that's how I got to 30. On the other side, I can have a look here. I've got 18. If I add the 2 to that, I get 20, and then I've got the 10 left, and that gives me 30. So what you can see there is it doesn't matter whether we do which way around we do it, we still get the same answer, which is pretty useful sometimes. In fact, I think it's probably more useful for children when we use it with the times, So let's say, for example, I had 4 times 8. I'm going, oh, sure, my 8 times table is not so good. 8, 16. And then I realize, hang on a second, my 4 times table is pretty good. So I'm going to say 8 times 4 instead. So 4, 8, 12, 16, 20, 24, 30, 28, 32, 32. And because we can use this with our commutative property, I will know without even having to learn my 8 times table that this one will also be 32. If I want to check, I can go 8, 16, 24, 32. So these are the same. Last one, these that I'm going to show you with the commutative property. Remembering commutative means we can change the order. They can commute from there to there or there to there. It doesn't matter. So commutative property only for plus and for times. Last example, 2 times 9. Ooh, 9. My 9 times table is not so good. Let me rather do 9 times 2 because my 2 times table is good. 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, that was 9 of them, 18. And because of the commutative property, I can now know that that one will be 18 too. So 9, 18, it is correct. So with commutative property, plus and times, we can change the order and still get the right answer. I am just going to move down the screen a little bit. This is not the commutative property. This is why the commutative property doesn't work with divide and minus. Let's say, for example, let me just put in a heading for anyone who's only half listening. So it doesn't work for division and subtraction. So 5 minus 1 is equal to 4. And 1 minus 5, ooh, that doesn't equal 4. Slip in some extra maths here. There's a special sign. That sign, where you cross out the equal sign, means doesn't equal. So 1 minus 5 does not equal 4. So you can see that for subtraction, the commutative property doesn't work. Let's try for division. 10 divided by 5 equals 2. 5 divided by 10. Because we've done fractions recently, it equals that. And 2 does not equal 5 over 10. So you can see that the commutative property doesn't work for times and division. It only works for plus and minus. Commutative property plus and times. Plus and times, not minus or division. The associative property. So again, this only works with addition and multiplication. This is the one that I think is particularly useful, and I'll show you why in a moment. So with addition and multiplication, if we only have addition or we only have multiplication, so not addition and multiplication, just one or the other, but if it's all plus or all times, then we can choose the order we do things and we still get the correct answer. I think that sounds a bit more confusing than it is in real life. Let me show you some examples. We'll put in a heading again. This is the associative property. And again, it's only with times and plus. Let us say, for example, that we have 3 plus 4 plus 1. On this side, I'm going to also put the same thing again. But on this side, on the left, I'm going to add those two together first. And on this side, I'm going to add those two together first. So 3 plus 4 is equal to 7. Plus 1, I didn't change the plus 1, it was still the same. And on this side, I've got the 3, which I didn't change, and 4 plus 1 is equal to 5. Next up, I'm going to do the part I'm underlining. 7 plus 1 is 8, 3 plus 5 is 8, and you can see that those two are equal. That's what I mean by it doesn't matter which order you do it in. You can do it that way or the other way, and it will still get you the right answer. In fact, and I'll squish this in a little bit on the right, I could also do it a third way. I'm going to do this quite small. And I'm going to add those two first. So I'm going to go 3. So let me actually work. So 3 plus 1 is 4, and then I'm going to leave the 4 there. 4 plus 4 is 8. So it doesn't matter which way you add them together, you will still get the right answer. That you can only do with plus and times. Let's look at one more example with plus. No, let's jump onto an example with times, and then I'll go back to another one with plus. So I'm going to do both of these. In the one on the left, I'm going to do this part first. In the one on the right, I'm going to do that part first. And like with the one above, I could also do 6 times 7 first. Doesn't make a difference. It will still give you the same answer because of the associative property of multiplication and plus. So 6 times 5 is 30. My times 7 will stay there. On this side, I've got 6 times, and I'm going to work out 5 times 7 is 35. See how knowing your times tables speeds things up. The next step is to do these two together. So 30 times 7. There's a little trick I will show you over here. So I'm going to cross that one out and put him down here. Right, he's smiling because he didn't have to do so much work. And now if I go 3 times 7, I get 21. And the answer to 30 times 7 is 210. On this side, I'm going to do this one for you. 6 times 35 is 210. I think this one on the right was definitely harder than the one on the left. I don't know about you. That one looked more tricky to me because working out 35 times 6 was harder because I couldn't do this little trick with moving the naught down. So for me, this one is easier than the other one. And that's actually why we use the associative property when you're doing mental maths or mental arithmetic, is so that you can solve those things nice and quick. Look at one more example of each. So when I look at this one, I could do it on the, I'm not going to draw it on the other side. The reason I'm going to show you this is where it becomes useful to do your, use your associative property. So I notice that if I add those two together, I get 10. So that's what I'm going to do first. And the reason for that is adding anything to 10 is easy. So I'm going to get 15 as my answer. And this is why it's useful that you can use it, that you can do any order. So I don't have to go 3 plus 5. I will write it on this side as well. I don't have to go 8 plus 7, which some of you might take longer with, which is also 15. I do it this way first because it's easier for me to get to 15 that way than the other way. Number 4. Doing a similar one with multiplication. So I'm going to do 5 times 17 times 2. And when I look at that one, doing 5 times 17 would be difficult. Doing 17 times 2 would be difficult. But if I did 5 times 2, that's easy. 5 times 2 is 10. Now I'm still going to times by my 17. I don't know if you know this little trick as well, but when we're timesing by 10, we can take this 0 and just put him on the end. So it becomes 17 from there with the 0 on the end. And there's my answer. And that is the same answer we would have got if we did that first, or if we did that first. It's just a much easier way of getting there, as far as I'm concerned. And that's the importance of knowing the commutative and associative rule, is it makes doing these kinds of things a little bit easier. I think it's important to understand the ones that don't work. We'll do one of each just to show that they don't work. Let's say, for example, I had 2 minus 7 minus 5. Let's make it 12 because we haven't done negative numbers yet. If I did the first part first, 12 minus 7, that's 5. 5 minus 5 is 0. On this side, I'm going to do the other part first. So 12 stays the same. 7 minus 5 is 2. 12 minus 2 is 10. And unless you do some very, very different maths to me, 0 does not equal 10. So it doesn't work with subtraction. Let's have a look at one with division. So we're going to do 100 divided by 20 divided by 5, and then 100 divided by 20 divided by 5. We're just going to change what we do first. So on this side, I will do this first. So 100 divided by 20 is 5. I'm jumping a little bit. I know that that is something I should probably explain. But otherwise, if I do, we're going to run out of time. Take my word for it that 100 divided by 20 is 5. If I divide that by 5, 5 divided by 5 gives me 1. On this side, I'm going to do this first. So 100 stays there, divided by 20 divided by 5 is 4. 100 divided by 5, again, I could show you the workings out for that, but we're going to run out of time. So 100 divided by 5 is 25. And again, unless your maths is very different from mine, 1 does not equal 25. If you do think that 1 equals 25, then please bring me 25 Rand, because I will give you 1 Rand and you can give me 25 Rand and we'll be quits because we will have traded an equal amount. So they do not equal. And the meaning of that is, or the important part of that is that the associative rule doesn't work for division or for subtraction. It only works for plus and a minus. Let's go back to looking at this. So if we look at the cumulative and the associative properties, they both only work for plus and times. They don't work for minus and division. Right, so commutative, we can change the order and get the right answer. Associative, we can choose which order we do things and we still get the right answer. So remember, associative will only work if it's all addition or all multiplication, not if you've got a combination of the two. I hope that was useful. Tomorrow we're going to add one more rule and practice a bit more. And hopefully by the end of tomorrow, you'll have all 3 of those rules done, and perhaps we'll throw in 2 more small things that you need to know in grade 5. Today's worksheet will look at the 2 rules we've practiced today and how we can use them. You can find that worksheet by clicking on the link at the top or above the video. Yes, and if you have any questions, please email me at grade5@worksheetcloud.com. It's very lonely here in my office, so the more questions you send me, the better. Have a wonderful day. Goodbye, grade 5s.